Okay, we're going over the homework from 1-7. Okay, problem number 1 asks us to solve for x to the nearest degree. And in this problem, we are given a right triangle. We know that one side is 8, we know that one side is 18, and we're trying to find this angle right here. Okay, so we're going to look at this angle. We know that this angle compared to this angle, the 8 is my opposite side, and compared to this angle, the 18 is my hypotenuse. And we know that from SOHCAHTOA, if I have opposite and hypotenuse, I'm going to use sine. So the sine of x degrees is my opposite, which is 8, over my hypotenuse, which is 18. But I don't want the sine of x, I want x. So I'm going to use the inverse sine. Remember, if I'm finding an angle, I use the inverse. So the inverse sine of 8 over 18 is approximately 26.3878 degrees. So it's going to be approximately 26 degrees. So the sine inverse of 8 over 18 is approximately 26 degrees. For problem number 2, we have a telephone pole that has broken, and we're trying to figure out how tall, well, we're trying to figure out the hypotenuse of the telephone pole, and then we can figure out how tall the pole was altogether if we want to do that. So in this case, I know two sides of a right triangle, so I'm going to use the Pythagorean theorem. So I've got c squared is equal to a squared plus b squared, or a squared plus b squared equals c squared, same thing. Okay, so I know that I'm trying to find my hypotenuse. I know that one side is 6. I know that the other leg is 11. All right, so 6 squared is 36. 11 squared is 121. All right, 36 plus 121 is 157. So I'm going to square root both sides. So C is approximately 12.5 feet. So the total height of the flagpole would be 6 plus approximately 12.5. So that would be about 18.5 feet. We were trying to figure out the whole height because it broke, remember? So it was this side and it was this side. Okay, in problem number 3, we're trying to find this angle right here. So we have to use a couple steps here. The first thing that we're going to do is notice that we have a triangle, and we know that the angles in a triangle always add up to 180 degrees. So I'm going to say 180 degrees is equal to 63 degrees plus 56 degrees plus whatever this is. Let's give it a variable. I'll call it y. Okay, so if those together are 180 degrees, I know that 63 plus 56 is 119. So I'm going to subtract 119 from both sides. And so I get 61 degrees for y. So if y is 61 degrees, I know that x and y together form a line. And we know that a line has 180 degrees. So once again, I'm going to make an equation set it equal to 180. In this case, I know that y is 61. So I'm just going to subtract that from 180. And x is 119 degrees. Okay, for problem number 4, we're told that two ladders are leaning against a wall at the same angle. Since we know that these angles are the same, we know that they both form right angles against the side of the building. We know that the third angles have to be the same, so that means they must be similar triangles. And we're trying to figure out the height of the little ladder. So since they're similar, we can set up a proportion. So we have 42 over x is equal to 30 over 10. So we solve a proportion by cross multiplying. So 42 times 10 is equal to 30x. All right, 42 times 10 is 420, and that's equal to 30x. So I'm going to divide both sides by 30. And my small ladder is 14 feet tall. Okay, for problem 5, we're told that line segment PQ is parallel to line segment BC. This is important. When we have parallel lines cut by a transversal, we end up with similar sets of angles, actually congruent sets of angles. So in this case, if PQ is parallel to BC, this angle is going to be the same as this angle, and this angle is going to be the same as this angle. The two triangles share angle A, so that means they're similar triangles. So once again, I can set up a proportion. So I'm going to say 6 over, in this case, I'm going to say that x is this whole side, because I want to be clear that we're comparing the two similar triangles here. So this is x. And I'm going to say 9 over the whole side. The whole side is going to be 21. So once again, we cross multiply. So I get 9x is equal to 6 times 21. 6 times 21 is 126. So that's 9x. I'm going to divide both sides by 9. So x is 14. And then to find BP, I'm just going to do 14 minus 6 is equal to 8 feet, which is BP. There are other ways to do this, but this is how I solved it. Okay, so for problem number 6, we are told that we have two roads that are parallel to one another, and we're told that the measure of angle 1 is 72 degrees. So I'm going to put 72 degrees here. And we know that vertical angles are always congruent. We know that when we have parallel lines cut by transversal, I can pick these angles up and I can move them down here. So that means this one's going to be congruent and this one's going to be congruent. So we're asked the measure of angle 4. So it is congruent to the measure of angle 1. So the measure of angle 4 is 72 degrees as well. Okay, once again for problem 7, we're dealing with parallel lines cut by a transversal. So in this case, we're trying to find the measure of angle 3. And we know that the measure of angle 1 is 2x plus 30. And we know that the measure of angle 2 is 6x minus 30. Okay, so let's figure out how 1 and 2 compare to one another. So 1, this is its vertical angle. It's going to be equal to measure angle 3 here. So since they're not the same, they're going to add to 180. So 2x plus 30 plus 6x minus 30 is going to equal 180. Well, the plus 30 and the minus 30 cancel, so we're left with 8x is equal to 180. Divide both sides by 8. X is going to equal 22.5 degrees. So x 22.5 degrees. I know that the measure of angle 3 is the same as the measure of angle 1. So the measure of angle 3 is 2x plus 30 is equal to the measure of angle 3. So 2 times 22.5 plus 30. Okay, so 22.5 times 2 is 45 plus 30. So the measure of angle 3 is 75 degrees. Measure of angle 3 is 75 degrees. Okay, once again, we're dealing with parallel lines. Now, in this case, these two form a straight line. So this shouldn't be too bad. Forming straight lines, 180 degrees, so they're going to add up to 180 degrees. So I'm just going to solve this. So 5x is equal to 100 degrees. Divide by 5. X is 20 degrees. Okay, once again, for problem number 9, we have two angles that form a straight line. So 2x plus 4x plus 30 is going to add up to 180 degrees. So that's 6x plus 30 is equal to 180 degrees. Subtract 30 for both sides. 6x is 150. Divide by 6. And x is 25 degrees.